day 2, we're just multiplying. We're doing row column. I will model. You can take shorter steps, but to begin, you're going to have to do this way. Before you start, no matter how long you do this, I want to see your orders. We know that the columns of the first have to equal the rows of the second, yes? So what you do is we're going to do A times B and B times A, so cut your slide like in half. So when I do AB, what is A? No, what's the dimensions of A?
-1,
No, 3 by 2. And we need to know if these are equal or not equal, okay? So I just put equal, so it's not equal, I do a line in between, right?
Yep.
Okay, what are the dimensions of B? 2 by 2, and then I circle these. Are they equal? Yes? So the answer is going to be a 3 by 2.
How do you get that?
3.
Oh, okay.
Okay, so we'll write out BA while we're doing that. So BA, what's the dimensions of B?
2 by 2.
2 by 2. And the net in A is 3 by 2.
So it's not.
So circle it. It's not. So the answer is undefined. Did you tell me why it's undefined?
Yes.
Yes. Now I'm going to tell you that's only going to happen like once. So if you get them all undefined and go, ooh, that was the easiest test ever, you did it wrong. Right? Okay, so we are going to take the first row times the first column, and then times the second column. So AB is going to be -1 times -3 plus 3 times -4. So -1, 3 is in the first row of A, right? And then -3, -4 was in the first column of B. So that is going to be one element. That's going to be your first element in your 3 by 2 matrix. Then you have to take your first row times your second column. So it's going to be -1 times 2 plus 3 times 1. So we finished the first row. Now we got to go to the second one and do the same thing. So we're doing 4 -2. So 4 times -3 minus 2 times -4. Everybody get where those numbers come from? Second row times first column. Now I have to take the second row by the second column. So it's going to be 4 times 2 minus 2 times 1. Now, why did I put a minus instead of plus? Because it's a -2. So, what do I have left to do? Third row, first column. So 5 times what? Plus 0 times -4. Bless you. And then 5 times 2 plus 0 times 1. Now I made my bracket way too big, like I usually do, and have to erase it. So let's stop and look at this. Do you see some patterns going on?
Yeah.
Do you see your row in your row?
Yeah.
Do you see your columns in your columns?
Mhm.
It should always look like that. If it doesn't, you did it wrong. Okay, I would encourage you for a while to write out all the work. Because people tend just to start putting 3 minus 12 and then they'll just try to do it all in their head. And what's going to happen? You're gonna get messed up, right? We're only spending a couple days on this, right? So now I just combine them. So I would have, I'll write it out. On this one, normally I would just do all that at once, but so 3 minus 12, and then negative 12 plus 8, negative 15 plus 0. And then negative 2 plus 3, 8 minus 2, and 10 plus 0. Because I've had people argue with me, well, I can see the pattern in this. You cannot see the pattern in this step, can you? No, it's non-existent there. So my final answer is what?
80 equals negative 9, negative 4, 1.
You going down or across?
I was going down,
Okay.
but 1, it doesn't matter.
Okay. So 1, negative 4,
6,
6, 15.
negative 15.
That negative's in the box. So it's not overly complicated, is it? But do you have to make sure you do row times column, and it's the entire row times the entire column makes one element. So if I could work out A times B and I couldn't work out B times A, does that make matrix multiplication commutative? No. Because if it was, I'd get the same answer for A times B and B times A, wouldn't I? So matrix multiplication is not commutative. So you're going to have problems that say do A times B and B times A. And sometimes they'll both work and sometimes they won't. And sometimes you will get the same answer. But not always. That one's the wrong one. Okay, so I've got A and B again, so I'm going to do A, B, B, A. Love my pen. A, B. So what are the dimensions of A?
2 by 3.
2 by 3. And a 3 by 2. So I'm going to end up with a 2 by 2.
How do we know we're supposed to take A times B?
It will tell you.
Oh.
I'm just doing A, B, B, A. So B, A, 3 by 2. And A,
2 by
2 by 3.
3. 2 by 3.
So I'm going to end up with a... Knowing what you're going to end up with, guys, is helpful. It helps you from not trying to do goofy stuff that you're not supposed to be doing. Okay, so... First row, first column. So 1 times what?
Negative 2.
Mm-hmm. And I'm just going to put, oh, well, I'll do it this time. But my next one, I'm just going to put 0. This time I'll write it out, but next time I'm just going to put 0. Why? Because it's 0 times anything is what? 0. Okay, so 0 times what? 1. Plus 3 times
Negative 1.
negative 1. And then 1 times 4 plus 0 times plus 3 times 1. You guys want to try the next one on your own? Keep going. Did you get negative 5, 7, negative 3, 6?
Yeah. I mixed up my -3 and 7. I don't know how I did it.
I bet you put your,
Oh.
you went down instead of across. Okay, when you look at your work, should you see your rows in rows and your columns in the column? If they don't line up like that, stop. When I start this every year, I do some and I make sure before I leave this first step that I see my rows and I see my columns. Okay? You guys want to try BAL on your own?
I have a pencil copy ratio. How do you do this one? Is it
I don't know.
-2?
Somewhere I do. But not right off the head. Okay, so now I'm going to take this row times this column.
Okay.
And if you need to rewrite it on the other side, then do that. Sometimes I'll write B on the other side just to make my brain easier for myself. Like that.
What is the second one in the third row? What's the first one? Is it just -0?
No, it's -1. It just, the 1 got into the parentheses. Now it's going to look like a plus. Pen just kind of decides to write where it's going to write. Okay, how'd it go? Did you guys get 6, -4, -14, 1, 0, 3, 1, -1, -5? Okay, again, is matrix multiplication commutative, guys? No. We got a 2 by 2 the first time and a 3 by 3 the second time. It is definitely not commutative. How do you think you feel about the process? Where? At what step?
Like the first part, like how do I know? Never mind.
No.
I'm kind of with you, Maddie. Like, I don't really. Like, I take -2.
So we took the first row, which was -2, -4.
Yeah.
And I've got to multiply it by the first column. So I have -2 times 1 plus 4 times 2. First thing times the first thing, second thing times the second thing. And then I go to the next column. So -2 times 0 plus 4 times -1. And then I go to the next column. I would keep going until all my columns are exhausted. That's why they have to match up with the columns of the first have to equal the rows of the second, because it won't work.
That's BA.
That was BA. And that's why I wrote B over here, because it's much easier to do that with having the B on the other side. And Maddie and Tori, do you see, when you get your work done, do you see your rows? Do you see your column? 1, 1, 2, 0, -1, 3, -2. Now, I did this problem, and I got this to be -7 right here the first time I did it. I'm like, what did I do? I didn't stop and look over here, and I had a 2 right there. Should I have known there was a problem there? Because what should I have? I should have -1, 1, -1, 1, -1, 1. So if you stop and take a second to verify that your rows are in your rows and your columns are in your columns, are you going to do this right every time? Okay, do another one. You guys want to try this one all on your own?
No.
So I
This
take,
one's easy.
I take 4 by 1, 4, 0 by 0.
Okay, is AB going to work?
Yeah. So it would be a
Because it's 3 times 3, a 3 by 3, and a 3 by 3. So they're both going to work in giving me 3 by 3s, yes? So for A, B, I'm going to take the first row times that first column.
So it'd be 1.
So it'd be 4 times 1/4 plus 0 times 0
Plus 0 times 2.
plus 0 times 0. And then I gotta go this row to the next column. Well, 4 times 0 is going to be 0. And 0 times -1/9 is going to be 0. And 0 times 0 is going to be what? 0.
Why do you do -1/9?
because it's,
Oh, okay, never mind.
okay?
I take it times the third column.
I take it times the third one, guess what I'm gonna get the whole time?
0.
0, 0, and 0. Because I'm gonna take 4 times 0 plus 0 times 0 plus 0 times 1/2. We got all zeros, right? So then I move to did I complete all my columns with the first row now?
No.
Yes. Now I move to what?
Second.
The second row. So the second row is going to be 0 times the fourth plus -9 times 0. That's horrible. I should put it in 9. And plus 0 times 0. And I'm going to have 0 times 0 plus the -9 again, evidently, times -1/9 plus 0 times 0. See how those zeros will just start being zeros instead of 0 times 4, right? And then I'm going to take 0 times 0 plus -9 times 0 plus 0 times 1/2. Now, did I finish all the columns with the second row? Yep. Yes.
I am getting lost. I'm getting confused with the multiplying of the rows and columns because like I thought with like 4, 0, 0 on A, you have to times like 4 going down, so like 4 times 1/4,
Mhm.
4 times 0, 4 times
No, it's
0.
each the first element with the first element, the second with the second, the third with the third.
That's so
This would be 4 times 1/4, 0 times 0, 0 times 0.
So are you going across or
I'm going row, column.
Yeah, that's what I thought you were. Yeah, that's what I said. I said 4 times 1/4.
Then you said 4 times 0. And it's 0 times 0. It's 4 times 1/4, 0 times 0, 0 times 0.
You don't take each number
Yeah, you don't take each number by every number. No, that would be horrible. So then I go the next one and I take 4 times 0, 0 times -1/9, 0 times 0. And the next one, 4 times 0, 0 times 0, 0 times 1/2.
So why'd you go back to 4? Why did you go back to 4?
You have to take the first row you have to take every row by every column. So I have to go that row times every single column till I'm done with the column.
When you use the third.
And then I would go, that was this one. That's the first row. Then I would go to the second row. So I had 0 times 1/4, -9 times 0, 0 times 0. It's my first term. Then I take 0 times 0, -1/9 times, -9 times -1/9, and then 0 times 0.
I think all the zeros are kind of confusing.
I like the zeros.
Because I'm looking at it and I'm like, okay, well this one is a whole, it's a number. So
Right.
I got them both to equal the same number.
Yeah, they do.
Okay.
So why'd you? Oh my god. Why'd you go back and forth?
I didn't go back and forth.
But
You didn't
4
vote on
times 0, right
Yeah.
there.
At the end.
Yeah, at the end.
No.
You take the first row by each one.
These, this is for, okay, if you're not working, if you're not working on this problem, we need to be quiet. Okay, so I have 4 times 0, 0 times 0, and 0 times 0. I have 4, 0, 0. Okay, and then I have 0 times 1/4, -9 times 0, 0 times 0. This row is all right now. Now I'm going to go to the last row. 0 times 1/4 plus 0 times 0 plus 5 times 0. Then the third row times the second column. So 0 times 0 plus 0 times negative 1/9 plus 5 times 0. Then I'm going to go to the next column. 0 times 0 plus 0 times 0 plus 5 times 1/2.
And where's the negative 1/9? Up on your first row. So
Oh, it should be right here. But it's 0 anyway. That's why I have 0 here.
She skipped a step.
Yeah, she just.
I just made it 0, because 0 times 1/9 is 0. Okay, does that help when I wrote out all the zeros this time?
Yeah.
Okay. So when I'm done with this, hopefully I can fit it in here. I get 1, 0, 0, 0, 1, 0, 0, 0, 5/2. So you guys try B8. I get all excited when I see all zeros because then I'm like, it's 0.
I was trying to write it like, just put the 0 plus 0. But I think it kind of confused me.
Maybe I try to make the leap too soon.
So I think the rows would be times the columns.
Yep, and so if you want to take and write B over here, my pen again is gross. I love how it doesn't work up there. If you want to write B on the other side of it, it'll make it easier.
Can they be community?
It can work, yes, but in matrix multiplication itself is not commutative. But you can end up with the same thing. Because what did you guys get? The same thing. Now, just because it worked one time does not mean it's going to work every single time, is it?
So do we have to write that it's,
That it's commutative? No.
how did you know it was gonna be?
Yeah, I don't know how
You
get
don't know. Your
that. I did
answer.
all
This
that
is your
stuff
answer.
quickly.
So you
What?
didn't work it out anyway?
I was on the second one.
No, keep going. Keep going.
Me neither.
Okay, guys, you cannot, well, unless you're multiplying by the identity, which we haven't seen yet, you are not going to know what your answer is going to be until you get there. Like, I can't see those two and say, oh, it's commutative. I can't. Don't. After you've done it a bunch of times, you can recognize patterns, but in general, there's not a rule. Does that make sense? There's not a.
Start under homework, or is there more to show?
I just want to show you the identity.
What's that?
Okay, just a second. Okay, the special relationship between this A and this B is they are inverses of each other, so they would multiply. No, these aren't inverses of each other. Yeah, they are. I don't know. Maybe not.
So if they're the same dimensions, their answers will be the same?
Nope. These numbers, what made this one all work to be the same?
Is the 1/4?
Look at, you got zeros everywhere except the diagonals, don't you?
Yeah.
Yeah. So the zeros everywhere are what made this commutative.
And where they're at.
And where they're at, yes. Them being on that main diagonal made the big difference.
So we don't write anything extra?
No. Nothing writing extra. Okay, we won't multiply this one out, but do they both work? Does A, B, and B?
No.
No, AB's undefined.
A, B, we've got 3 by 3, right? And 3 by 1. So is AB going to work?
Yeah.
AB is going to be a what?
3 by 1.
A 3 by 1. What about BA?
Nope.
Undefined.
So it'd be 3 by 1, I gotta show why, right? And 3 by 3, not equal and undefined. Okay, if you guys think you're good on the process, I do want to do the last one, though. So let me know when you guys finish that other one.
Wait, do we work out AB?
Well, as a class, we're not going to. If you would like to,
Oh,
I have
right.
the answer and you can check it.
Okay.
Is everyone finished with the last one?
What?
Are you finished with the last
Well,
one?
I'm just gonna go back to it later because I'll take certain hours.
Okay. But you know what it's supposed to be, right? Okay. So, is ABBA going to work here?
Yes.
Yeah, because they're 2 by 2. What do you notice about B?
There,
It looks,
that row echelon stuff.
It's in row echelon form. Okay? 1001 is the identity matrix for a 2 by 2. What do you think a 3 by 3 identity matrix looks like?
1, 0, 0, 0, 1, 0, 0, 0.
Right. So identity matrices only happen on square matrices. So 2 by 2, 3 by 3, 4 by 4, 10 by 10, because you can have a main diagonal, can't you? If it's not a squared matrix, can I have a main diagonal? No. So if it is a square matrix, it has an identity, and that identity is zeros everywhere except the main diagonal, which is 1s. You were finding the identity matrix every time you're doing Gas-Jordan elimination. Okay, you were finding the identity matrix for a 3 by 3 or a 2 by 2. So what do you think is going to happen when I take A, B, and BA?
I got the same as A.
You think it's going to be the same?
I know it's gonna be
Okay,
the same.
so 3 times what? 1 plus 4 times 0. And 3 times 0 plus 4 times 1. And negative 2 times 1 plus 5 times 0. Negative 2 times 0 plus 5 times 1. I don't think we need the interim step here, do we?
No.
No. I get what?
Same
3,
thing as A.
4, negative 2, 5.
So will you be able to identify that before you even do the problem?
Mm-hmm. So BA, let's prove that to ourselves. 1 times what? 3 plus 0 times 1 times 4 plus 0 times 5, and then 0 times 3 plus 1 times, and this is really hard for me to keep them straight here, 0 times 4 plus 1 times 5. I really, guys, have to write the B on the other side of A. I can do it, and I did it, but it is not efficient. It is more efficient for me just to write B on the other side of A and do it than to spend all that extra brain power going backwards. Does that make sense to everybody? Because I'll find myself going row times the last column and working my way left. Is that going to work, right? No. So if you're struggling with doing the B, write the B on the other side of A and quit trying to make yourself work that hard, okay? It's not worth it. Okay, so then what do I get? 3, 4, negative 2, 5. So in this case, was it commutative? Yes. Matrix multiplication by the identity is commutative, okay? But only by the identity. And does every matrix have an identity? No, because not every matrix is a square matrix, is it?
No.
Okay? So this is what you're doing today, you're multiplying. And just because it's big, don't not do it, guys. I heard that. I didn't do it, it's too big. That's it. That's all I got. Those of you that didn't finish those other ones, finish them up and we'll make sure you got them right. Yes. Yes.